Hey guys, hope everybody's enjoying their coronacation, as I've been calling it. Um, so have out your Unit 11 packets. We're going to be on day 5 today. This is the lesson that we were supposed to do on Monday, but then life as we know it ended. So now we're doing it from computers. So have out your packet, day 5, and let's get started with this. Hopefully the Delta math wasn't too bad for you guys. It was just day 4 and a little bit of review from before day 4. Um, but let's get this going here. So, here we're solving quadratic and linear systems, but instead we're going to do it algebraically. So day 4 was solving it graphically. So to do this, two equations have to be given to you, right? One equation has to be a quadratic, and that is an equation with a degree of 2, right? ax squared plus bx plus c. That's a quadratic equation. Got to have a degree of 2. The second equation will be linear. That has a degree of 1. Y equals mx plus b. It's a linear equation. That's what it looks like. Now, here are the steps in order to do this. Step 1, make sure both equations are in y equals form if necessary. You always got to make sure that you have both into y equals. Huge. Step 2, substitute the linear equation into the y part of the quadratic equation. That makes sense because then we're going to have only one variable left. And you'll see what that means when we get to it. Step 3, you want to get your new quadratic equation into standard form, which is, of course, y equals ax squared plus bx plus c. And then when you do that, you have to solve for x. Step 4, since it is a quadratic, you must factor to solve for x. So how many answers should you get if you have a quadratic, which is x squared? Hopefully you should get 2 values for x, right? Your plus or minus. Step 5, you got to find the other variable, which would be y, by substituting your x into one of the equations and solving for y. So this is kind of like solving linear system of equations, except now it's solving system of equations with a quadratic. Okay, so it's really not all that different from what we did a few units back. So number 1, solve the following system of equations. We have y equals x squared minus 2x plus 2, and y equals 2x. Well, we always want to take our linear equation, y equals 2x, and we're going to substitute this piece in for this y, right? So when I do that, I'm going to have something that looks like this. 2x equals x squared minus x plus 2. And then I got to solve for x. Now recall, this is an x squared, so I want to move everything to one side because I'm going to have to factor it out because of that squared. So let's subtract 2x from both sides. That cancels out on the left side. So I'm left with 0 on this left side is equal to x squared minus 3x plus 2. And hopefully that just now is screaming to you, Xbox, right? What multiplies to a times c, which would be 2? But what adds to b, which is negative 3? Well, it's negative 2 and negative 1. Multiplies to 2, adds to negative 3. So what we get is 0 is equal to x squared minus 2x minus 1x plus 2. And then we bring down our wall, and GCF on this left side would be x minus 2 this sign right here comes down, so it's minus. GCF on the right side would be 1. X minus 2. Matchy matchy leftovers. So x minus 2 and x minus 1 all set equal to 0. And so should that. Okay. Remember how you solve for x, right? We get into this form, but now we have to set each one of these equal to 0. So x minus 2 equals 0 and x equals 1. Oh, well, okay. I guess I just skipped a step, but so x equals 2 and x equals 1. Okay. Now, think, did we solve the question? Did we solve the system? No, a system has to be coordinate points, right? So I have an x value of 1 and an x value of 2. So that doesn't mean I'm done. That just means that my answer is definitely going to be 2 comma blank. What's my y value here? And 1 comma blank. What's my y value here? So I got to solve for these. And the way I do that is I'm going to bring this all the way over here. I have x equals 2 and x equals 1. I'm going to take those two x values of x equals 2 and x equals 1, and I'm going to substitute them in to my linear equation right here to solve for my y value. So it's going to be y equals 2 times x, which in this case is 2. Okay, so I get y equals 4 for this case. So in this case, my coordinate point is 2 comma 4, right? And that would match down here. So this value really is 4. And then up here, I'm going to do the same thing for x equals 1. It's going to be y equals, and again, I'm using this linear equation. So 2 times x, which is just 1. So y equals 2. So this coordinate point is 1 comma 2. And that is my answer right here. Right, we just solved the system, and this makes sense, right? These are the two intersection points where this graph would cross. So just like a sketch, it would look something like probably like this. And these represent those 2 points, just like we did in day 4, right? Here's 1 point, say 2 comma 4, and then another point 1 comma 2, something like that. Okay, and that's the basis of this lesson, solving systems. It's just instead of doing elimination, it's substitution. So let's go on to the next one. Number 2, find the solutions of y equals negative x squared plus 4x minus 3 and x plus y equals 1. Okay, recall that we need to make sure both equations are in y equals form. So right here, y equals is good, but here I have x plus y. That is not so good. We're going to have to get y by itself for this bottom piece. So let's subtract x from both sides. So I have y equals negative x plus 1. Okay, so now when I get my linear equation into y equals form, this piece right here is going in. I'm going to substitute it in for this y value here. Okay, so let's do that. Let's solve this. I'm going to have negative x plus 1 equal to negative x squared plus 4x minus 3. Now think about what I got to do here. I definitely have to move everything to one side. Either all this to this side or all of this to this side. What would be the smart thing to do? Think. You could move the x and the 1 over to this side, but I see this negative x squared. So what I'm going to do is I'm going to add x squared to both sides because I don't want to work with a negative x squared, right? Which means I'm also going to subtract this 4x, which means I'm also going to add this 3. All right, and think about why we did that, because I don't want this negative x squared. So on this left side now, I will have x squared minus 5x plus 4 all equal to 0. Again, go ahead, do your Xbox. You guys should practice this. I'm going to skip a few steps here. I'm just going to get down to what the answer would be. Okay, so this is what we should get after we do our wall and we do matchy-matchy leftovers. All right, so this is what we get to, which means that solving for x, I will get x is equal to 4 and 1. But again, this is not my final answer. I need intersection points. These are just x values, which is good that I have 2, because I do need 2 intersection points, one of which x is equal to 4, and another where x is equal to 1. So now what I'm going to do is I'm going to take my linear equation, y equals negative x plus 1, and I'm going to substitute in for x. So y equals negative x, which is 4, plus 1. So I get y is equal to negative 3. So this coordinate point is 4, comma, negative 3. And then for this piece, y equals negative x, which is negative 1, plus 1. So y equals 0. So this coordinate point is 1, comma, 0. And that is my answer. All right, these are my 2 coordinate points, my 2 intersection points of where these graphs would cross. All right, if you need, pause the video, get anything you need down. And I think we're on to our last problem. Number 3. Let's go to blue, because blue's nice. Solve for the solutions. Y equals x squared minus 7x plus 13, and x minus y equals 2. This second piece will not work. We gotta get y by itself, so let's subtract x from both sides. I'll be left with a negative y equals negative x plus 2. Negative y will not work. I'll have to divide everything by negative 1. Divide by negative 1, divide by negative 1, divide by negative 1. That way that cancels out. So I really have y is equal to x minus 2. All right, sweet. Now I can take this piece, x minus 2, and substitute it in for this y value, and then solve. So I'll have x minus 2 equals x squared minus 7x plus 13. Subtract x, add 2, right, because it's an x squared, so I gotta get everything to one side. That cancels out. I'm left with 0 is equal to x squared minus 8x plus 15. Again, hopefully this is telling you Xbox. Make your wall. What multiplies to 15 but adds to negative 8? Right. That should be negative 5 and negative 3. Do your matchy-matchy leftovers over here. Make your wall. Your answer that you should get is x minus 5 times x minus 3 equal to 0, which means that x equals 5 and x equals 3, which is good, but not fully there yet. We got to find each corresponding y value for when x equals 5 and for when x equals 3. And again, all I'm doing is I'm going to take my linear equation and substitute in for x to find my y value. So I'll have y equals x minus 2, but I know that x is 5. So it's 5 minus 2, which means that y is 3, which means I have a coordinate point of 5, comma 3. And do the same thing over here. Y equals x minus 2. Well, x is 3 minus 2. So y is 1. So this coordinate point is 3, comma 1. And those are my two coordinate points. That's a terrible square, but whatever. Those are the two coordinate points for this solution as well. Okay? Now, for the homework, guys, on the next page, 11-5, I want you guys to give, don't do that yet. I think I'll assign that for tomorrow. Try and keep the workload light. So just get these notes down. I want you guys to send me pictures. You can either send it through email or through Google Classroom. Send me a picture of your completed notes with your name on top. Okay, I need to see the name on top for you guys to get credit. And I hope you guys have a great day. Other